So today we're going to culminate all the factoring we've been doing to get to be able to factor a quadratic. Remember, a quadratic is anything of the form ax squared plus bx plus c. You should write this down. And again, we already know all the basic tools to get us to factor a quadratic. We're just going to put it all together today. So first thing in the process, again, this part right here just kind of tells us what the process is. We are going to use the x factor, so the x puzzles, to write the quadratic with 4 terms. Remember, we cannot use grouping unless we have 4 terms. So that x factor splits from 3 terms to 4 terms. And if we only have 2 terms, we're going to add in that 0x. And then we just factor by grouping. All right, let's go ahead and look at the first example. We're just going to do the same thing we were doing previously, not much of a difference. So we're going to go ahead and take the first term and the last term. That doesn't look so good. Let's use the actual pen. We're going to take the first term and the last term, and we're going to multiply. The invisible 1 times 14 gives me 14. Let's change the color on that. And the middle term goes at the bottom. Again, we did this last week. It's not too difficult. Ask ourselves, what are the 2 numbers that multiply to 14 and add up to 9? If you said 7 times 2, you are correct. So we're going to go ahead and erase that. So we're going to just rewrite this from 3 terms to 4 terms using our solutions to the x factor. So we're going to keep our first term. Our second term is going to get replaced for 7x, or 7k I should say, plus 2k. And then bring down the 14. So what I just wrote is an equivalent expression to the original quadratic. I'm allowed to do this because these 2 add up back to 9. I know there are other numbers that add up to 9, like 1 plus 8 or 3 plus 6, but 7 and 2 is a specific one I want that's actually going to allow me to factor. And now I'm going to go ahead and factor, and I'm going to factor by grouping. So I make my 2 groups of 2, and I check out what's in common in each one. First term, k times k, 7 times k, they have a k in common, so I'm going to factor out the k. So here's the k in common. So k, I get k plus 7 as my leftovers. On the second one, I have 2 times k and 2 times 14 because 2 is divisible into both numbers. And 2 times 7, 2 is divisible into both numbers. So 2 is my GCF, which is what I'm going to factor out. So that's positive 2, k plus 7. And what I want to happen has happened, which is the 2 binomials are the same. That's my new GCF for the final factoring piece. And I'm left over with k plus 2. So I have my answer, which is the binomials k plus 7 and k plus 2. We're going to go ahead and move on to the next problem. All right, we're going to, again, repeat the same process. If you want to go ahead and pause it and then just go ahead and do it on your own and then check the answers, feel free to do that for every problem. Otherwise, just follow along. So I'm going to start off by multiplying my first and last terms. These go at the top, so I'm just going to go ahead and get 56 and 15. Ask yourselves what numbers multiply to the top and give us a solution to the bottom when we combine. If you said 7 times 8, you are correct. Now I'm going to go ahead and rewrite my quadratic from 3 terms to 4 terms. We're using the 7 and 8, which were the solutions to my x factor. The x factor tells me how to break it down so that I can use factoring by grouping. Otherwise, it will not come out nicely. I'm going to go ahead and factor by grouping now, split my 2 groups. Ask myself, what do these have in common? These have in common x. For this kind of problem, you will always have a x as a GCF for the first piece. One more time. For the quadratics, you'll have an x for the GCF, and sometimes a number, sometimes not a number, but x will always be part of the GCF. For the second one, you'll always just have a number for the GCF. 8 divides both of these. So one more time, only a number will ever be the GCF for the second half. You will not have a letter because this last term will never have a letter. So you cannot have a letter in the GCF there. So x plus 7 is my Binomial, again, binomials match. That's my GCF for the last factoring, and I'm left with x plus 8. Final answer, and I'm done. Let's go ahead and move on to the next problem. That's not moving me to the next problem. All right, let me actually have to move it on the computer. Let's exit the drawing mode. All right, give it a second to move. There we go. All right, that should be big enough. Go ahead and zoom in on this. So let's go ahead and move on to this next problem, number 3. So again, same process all over again. Multiply the first term times the last term. Here I actually have a number in the front, so I have to be careful. That's actually a 6. Bottom is a -5. Ask myself what multiplies to 6 and combines or adds up to a -5. So if I try 6 times 1, those will not work because they will give me 7 when I add them, so I don't use that. So I need to use 3 times 2, but that gives me a +5, so I make them both negative. That gives me a -5. So I'm going to go ahead and take my middle term and split it. Keep the first term. Sorry, some stuff is happening here in my screen. All right, there we go. 3a squared minus 3a minus 2a plus 2. So again, I split the middle term. Still equivalent. Go ahead and factor by grouping again. So my GCF here for sure always has a variable. In this case, it's an a. So I'm going to go ahead and write them out. 3a minus 3a. So they both have a 3a in common. So my GCF is 3a. And I'm left with a minus, and there's nothing left here, so I have to put my placeholder of a 1. You can always multiply by 1 and it doesn't change. Second half, my GCF is just a number, which is going to be a 2 in this case. But in this case, I need to think of the fact that I want to match it up to the first one, which has a negative in the middle. This one has a positive. So in this case, I definitely want to factor out a GCF of a negative. So I'm going to put a negative on both the 2 and the 1. So when I factor out my negative, it switches the sign. So my GCF is -2, a minus 1. Just another side note, if you ever have a 2 in the third term, you will generally, right there, you will generally always factor out a negative, which switches the signs. Now just to wrap it up, we have a minus 1 as my GCF, and leftovers 3a, or the rest, -2. Let's move on to the last problem. Again, I want you guys to try this last one on your own. Pause the video and check the answer in a few seconds. So now that you're done with number 4, let's go ahead and check your work. So in this case, we are missing that middle term. So again, it's kind of up to you in this case if you want to actually write it out with the 0. You actually don't really have to write it out with a 0. It doesn't make a difference at the end. So if you want to skip this step in blue, it's perfectly fine. You don't actually have to write it down. But if it helps you to write it down, write it down. You can go straight to the -16 here. And 0, with or without writing that blue step. So it's your call. Solution to the diamond is 4, -4. So m squared plus 4. And that should have not been x, now that I think about it. Let's go back and fix that. That should be an m. Let's actually erase that. 0m. So we have 4m at this point, minus 4m, minus 16. Again, factor by grouping again. So in this case, I'm not going to write out all the little letters this time, but you can see they have an m in common. We have an m plus 4 left over. This time we have a -4 in common. Double check that you made yours negative because you want to switch the signs. So we have n m minus plus 4 in common. So m plus 4 and m minus 4 are my two factors that multiply back to m squared minus 16. All right, that's pretty much it. Your task is to now go ahead and do the practice problems, all 12 of them, Answers are at the end of the next page, so you can check your work, and then don't forget to go back to the first page under the Do Now and do the error analysis problems. Go ahead and get started, and good luck.